So it's the Python webinar. We'll be discussing four topics in this webinar, and it will be considered as a level 2 or intermediate to advanced manipulation with Python. So I'll try to go through my slides, and in parallel I will manipulate examples in the Python editor. So I'll ask you again to turn off your mic in order to make it
هم عايزين ايه؟
participants.
انا فاهمهم بقى هم عايزين
We are going. Can you please turn off your mic؟ لو سمحتوا تطفوا الميكروفون.
نشتغل عليه شويه، نعدي حاجه
لو
ناخد،
سمحتوا
نعدي
الميكروفون.
ناخد كل حاجه ناخد. لما نيجي جبت حد بقى بقول لهم لا اديني الحاجه بتاعتي.
لو سمحتوا الميكروفون.
وهي مالها بتدفع لا ولا بدفع يعني.
Okay, so now you are muted in order to let me perform this webinar. So in this webinar, we'll be working on loops, embedded loops, manipulating lists and array, Python libraries, and I'll be giving you one example, and procedures and sub-procedures. The idea of this webinar is to help you transmit the information to your students in order to understand better the idea and the concept of coding in Python. So as you all know, Python is a free coding language used in major field of applications due to its wide number of resources and libraries, and this code is, or the syntax is simple to manipulate. You have to know that, and you have to tell your students that there is an offline version for Windows or for other operating system, and there is an online version in case your students are working on a tablet or a phone. They can manipulate Python using an online version for Python. And of course, you need an editor like PyCharm, like MU. There is many editor to perform the programming in Python, but I choose MU for a specific reason. I will tell you later on why I choose MU. You can choose PyCharm or any other, but I use it for a reason that we'll be discussing in later on in this webinar. So today, as we said, mastering loop, embedded loop, lists, array, Python libraries, and procedure and sub-procedure. I'll be asking you at the end of this webinar to send your name and your email and the school name on this WhatsApp number. It's mine, in order to receive your certificate of participation. It's very important to receive this certificate in order to add it to your CV. So as we all know that today ICT is considered as a science to be delivered to students from grade 3 till grade 12, and since we cannot give one language from lower grade till grade 12, we decided in the right-click curriculum to split the coding language into three, which are Scratch from grade 3 till grade 6, Small Basic from grade 7 till grade 9, and Python from grade 10 till grade 12. Last week, when I animated the Small Basic webinar, I told you that we can start from grade 7 teaching Python But the idea is that students will get bored, go bored if bored, sorry, if we started from grade 7 till grade 12. So we have to change to give them more than coding language in order to show them the different way of writing syntax, knowing that the algorithm is the same, but the syntax will change. Uh, Now I will start by looping and embedded looping, and as you know, and this is what you have to say to your students, that we cannot imagine any application, any computer program without looping and without embedded looping. And of course, you will have to explain them that a loop is a function, or it's a instruction that will turn and repeat all instructions that are inside. The difference between embedded or nested loop and loops is that loops are it's a one structure. uh, Embedded loops are loops inside a loop. So what is the benefit from using embedded loop? It's very simple. It's the way to perform multiple tasks or complicated tasks in order to repeat another repeat. This is the way we say it. So in this program, I will switch in a few seconds to the MU program. In this program, we can see that I'm using the for loop. And please do say to your students that for all computer languages, there are only two structure for loops, which are the for loop and the while loop. The difference between the for loop and the while loop, I believe that you know it. In the while loop, I have to declare a counter, I have to set a condition, and I have to increment, increase, or decrease the counter. In the for loop, all is built in the first line. Of course, you will receive questions maybe from your students saying why we have two kind of loops. It's very easy. There is some manipulation that can't be done in while or in for. That's why we have those two options. It's not the time now to discuss the difference between both, but in our tutorials hosted on the YouTube channel, you will find it in an easy way. So sorry. So as you can see here, the syntax in Python all is written in lowercase first. Second, the for loop should be ended with a 2 points at the first line. And while you type enter, there is one indentation in order to make Python understand that all the commands with one tabulation inside are executed in the for loop. For x in range -5 till 18, print x. This will print -5, -4, -3, -2 till the value 17. Also, students must know that the value, the maximum value is not reached. It's always -1. So if you type -5, 18, it will reach to 17, since the -5, the first round is counted. The second loop, it's a second kind of loop. Here we are talking about loop, simple loop, not embedded loop, in order to pass to the embedded loop. And that's how you should proceed with your students, knowing that in our curriculum, starting from grade 7 or 8, students start manipulating loops in small basic. So it will be easy for them to understand the logic of loops in higher grades. So from turtle import asterisk. Okay, so here I'm calling my library turtle, and then after from I equal in range 0 to 4, it means that the loop will turn 0, 1, 2, 3. It will stop till value 3, but actually it's running 4 times. The turtle will move forward 70, and then it will turn right 90 degrees. Is a third way of writing a loop for a specific manipulation is to input names. So here in line 9 and 10, you see for j in range 4 to 7, name equal input your name. So the user will be asked to type his name or names 4, 5, 6, 3 times. Okay. And then after for I in range 4 to 17, print I, it's like the first one. And then same thing for the last loop, which is line 15 to 16. And then it's asking to input grades. So by this slide, you see that there is many manipulation that we can perform in a loop. Here we gave the first one to display numbers, the second one to draw figures in the turtle, and the third one is to create a dialogue between the user and the computer. So I will pass directly to this slide where you can see embedded loop, and here students must understand that I have inserted another loop in the first one. On line 1, it's the first loop. On line 2, it's the second loop. And as you can see, there is one tabulation for this loop. So it means that the small loop for line 2 to 3, it will run 4, 5, 6, 7, 8, 5 times. And the bigger loop, which is on line 1, it will turn 0, 1, 2, 3, 4, 5 times. So, and what will be the result? It is printing or displaying on the screen X and Y. So you have to imagine that 0 will be printed, 04, 05, 06, 07, 14, 15, 16, 17, and so on. I will go directly to let me just open, it's the loop. I believe it's this one. Just 1 second. Okay, this is it. So once I run this program, you can see that the result will be 04, 05, 06 till 07, 14 till 17, 24 till 27, 34 till 37, 44 till 47. So this is what we call an embedded loop, and it's a simplest way to make students understand how they are performed. I mean, if you add to this program, for example, print, let's say TTT, okay, as a text, and once you will run it, look what will be the result. So for each run of the small loop, the 3 letters TTT are displayed. So also here, students will make or will understand in a better way this Okay, so I'll try to close it. At the end of this webinar, I will send you all the examples in Python in order to practice them or to send them to your students in case you don't have the time to retype them and so on. So I will close this one. This one is already done. Okay, another example of the loop, of the embedded loop, if we try to see together, is this example where we have two embedded loops. The first one for x in range 0 to 3, it means that it will turn 0, 1, 2, 3 times. For each time, the user is asked to type the student's name. At line 3, a variable is declared named total, and the value 0 is assigned to it. And for each turn of the big loop, there is a small loop for y in range 0 to 3. Also here, we are asked to type 3 times the grades of each student. So imagine that once we run this program, okay, the user will type a name, then he will be asked to type 3 grades for this student. The total on line 6, as you can see, will be accumulated, will be added, and once the small loop is finished or terminated, the program will display average grade for student called its name is total divided by 3. So it's a typical program also to explain in another way how we can embed a loop inside a loop. And here, please believe me that if you reach this level with your students in making understand them this kind of programming, all right, it's very important, and you can say that your students reach the level that is set for them, or you want them to be there. Okay, regarding the assessments, of course, there is many idea of assessments in Python. So I'm trying to write, not to forget. So send Python exercises, and then assessment template, in order to show you what kind of assessment and exercises we can send them to be done in written. So if I switch to this program and run it, so the first thing is to type the name, grades 12, 14, 16. So look here, the average of student we sum is 14. And here we are asked to type another name, 14, 18, 19. The average of Adel is 17, and so on. So once we reach this level with our students, I believe that we did a great job in teaching them those concepts of programming. Here also, a third example of type of example manipulation that we are performing with the embedded loop, which is on line 1, I import the library turtle. And as you can see on line 2, I'm performing a loop from 0, 1, 2, 3, so 4 times. And in a second loop, I'm performing 0, 1, 2, 3 times, okay? Forward 50, right 120, it means that it will draw a triangle. And once the triangle is done, the turtle will move forward 70 and then turn right 90. So let's see what is the result of this program. So as you can see, the turtle is drawing a triangle, then it's moving 70 and turning 90 degrees. And look what the result that I've obtained in the embedded loop. So I will review quickly. I show you how to use the embedded loop in order to display numbers. And here there is no limit for giving examples to your students, believe me. Okay. The second example is how to use the embedded loop in order to, is there any, the window is not shared? It's not shared, the windows? No, it's sharing. I'm sharing all the screen. Maybe when I run maybe when I run the turtle is not shown. I don't have any idea. So excuse me. The second example of the embedded loop is how to use embedded loop in order to create a dialogue between the user and the computer, typing a name, then many numbers for the for the student. And the third one is how to draw figures using embedded loop to obtain complicated figures. So I believe that for the time being, if you reach those three type of example of the using the loops, I believe it will be great. And then extra, I will be writing extra example of embedded loop to be sent. Okay, now I'll move to arrays and lists. And also this topic, I've done it last Thursday, was small basic. And also in order to make your students understand in a clear way the idea of what is array, you have to start your lesson by making a revision about what is a variable. And here, by explaining them that a variable is a location in the memory of the computer that has a unique name, and the content can change anytime I make an assignment, let's say x equal 10 or x equal 20. So I'm changing the content of this variable. And then the variable is compared to a house. It's very important, believe me, from my own experience, to give this example, since once we will move to the lists or the arrays, we have to compare them to a building where we have one building with many floors, and in each floor we can assign a specific information. As you can see here, the array or the list is A. On A0, it's the first item, we have 12. On A1, we have 7, and so on. So this introduction is very important for you to give to your students in order to make them understand more the idea of what is array. And during your written assessment, believe me, you can ask them to what we can compare a variable, or to what we can compare an array, and they are supposed to answer by a house or a building. After this introduction, okay, I will go directly to the first program, which is a little bit different than small basic, is how to create an array and how to fill it. So by looking to this example, x equal brackets, so you can see that I'm defining an empty array named x, and in a loop for I in range 0 to 4, okay, x dot append. Append, it's the property to add to the array a new item. So x dot append ent, which means integer. So I'm telling Python that the value I will type, it will be integer. If you want it float, decimal value, So you can write instead of int float, and then the function input, as you all know, it's to accept information, and the sentence that will be displayed in order to guide the user what to type is between quote type the content of the array number. So this program, formed of 3 lines only, is to fill in the array of 3 items. Now, for 4 items, sorry, 0, 1, 2, 3, 4 items. So the second slide will show you how to print the content of the array. So the first 3 line is to add, to fill in the content, but no sense for this program if we cannot see the result of what we are filling. So that's why on line 5 and 6, we added a new loop in order to display the content of I in the form print type the content of the array number, comma, I is, comma, x of I. So once I run the program, I will show it to you. So this one is done. So look here, if I run the program, I will be asking to fill in the numbers. So 14, 15, 16, 17. Okay, and as you can see, the values will be for case number 0 is 14, 15, 16, and 17. The rest, we will see it right now. But before I forget why I'm using mu for Python, okay, and not any other one. Since in this editor, if you can see here with the mode, okay, you can switch to the BBC microbit microcontroller that we are going to animate in the near future, a seminar, a webinar regarding the microbit, which is a microcontroller that can, like the Arduino, but for lower grades. So since this MU give us this option to program in Python a microbit, so it's an advantage for you and for your students in order to manipulate it and not to install many editor. Plus that the MU is light, it does not need a higher configuration of computer, and there is an online version of it, so you can go through the iPad or the telephone in order to manipulate this this editor. So back to my program for the arrays. So in the second loop, I'm displaying the content of the array in a correct way. I mean, from 0 to case number 4, to item number 4. In the third loop, for I in range, here we'll start from 3 till -1, and the -1 here is the step. I mean, going back in a reverse way. Okay, so you will see that the last item in case number 3 will be displayed, then the case before, and to reach the first case. So if I run it again, so 14, 15, 16, 17, as you can see, the first 4 items are 14, 15, 16, 17, and then the second loop is 17, 16, 14, 15, and 14. Then you have to know something very important, and you have to tell your students that we cannot manipulate an array without a loop in an automatic way, since the loop will turn the array in a logical and automatic way. That's why always arrays are manipulated with loops. So here, as you can see, the first loop is to create and to fill the array. The second loop is to display the content in a increasing way of elements. And the third loop is to display the content of the array in a decreasing way, starting from item 3 to reach the item number 0. Okay, I will close this one and I will move to the this one is done. This one is done. And we arrive to what we call manipulating multiple arrays. Here, the challenge will be higher since, let's say, I want to create a program to accept many names, many grade for math and ICT for those names, and each item should be stored in one array. I mean, the first element of the array for the array name will store the name, and in the array math and in the array ICT will store the grades of this corresponding name. That's why here you can see on line 1, 2, 3 that I've declared 3 arrays: name, math, and ICT. And in the loop from line 4 till line 7, I'm running a loop 0, 1, 2, 3, 4 times, and I'm appending my arrays in order to add the student name, the math grade, and the ICT, each information in a separate array in order to manipulate it later on. So I will try to show you this program. Once I run it, I will write the name of the student, the math grade 14, the ICT grade is 16, another one 15, 14, and so on. Here, what we can add to this program, okay, simply we can add a procedure or a routine in order to display each name. Can you turn off your mic, please? يا ريت تطفوا الميكروفون لو سمحتوا. الميكروفون لو سمحتوا. Okay, so here you can add to this program, or you can ask your students to complete this program by writing the loop in order to calculate for each student the average of grades, and then after to display them. And even the average could be added in a separate array that you can create below the program. So I'm trying to tell you that there is no limit for what we call creating, inventing new exercises, or completing or adding exercises for arrays. Then after, I will go through this program, which is searching for an item in a list. Here also, we've did this manipulation in small basic. We'll see it in Python. So as you can see here, line 1, I've declared, let us go to this program. Okay. In line 1, I've declared the list or the array X. In line 2 to 3, I'm filling in the content of the array. On line 6, I'm asking the user to type the item I want to search, okay, to see if it exists in the array. And by default, I'm declaring a variable named find, and I'm assuming that this variable contains false. I mean, I'm assuming that I will not find the value I'm searching. And while searching, if the value is found, I will switch the content of the variable find to true, as you will see in the following lines from 9 till 11. So look at the loop 4, I in range 0 to 4. I'm asking the computer to evaluate the item of the array with the item I'm searching. And if they are equal, look what I'm doing. I'm assigning to the variable find the value true. So, and at the end of the program, if find equal, as you can see, in order to make this comparison in Python, it's not one equal. The one equal is to assign values, but the double equal is to make a comparison. So if find equal true, then I will print the item is found, else the item is not found. Let me try the program. The content of the array 14, 15, 16, 17. Item to search 8. The item is not found. And then after, if I type 14, 15, 16, 17, the item to search is 15. The item is found in the list. Here, let me open a small bracket and to tell you that coding, as we all know, is the main gate to what we call STEAM education, IoT, artificial intelligence. And as you can see, if you are using our curriculum, right click, and I believe most of you are using this curriculum. And for those who are not using, I invite you highly to ask for the catalog or the specimen in order to know better our collection. We are on the market since more than 20 years. So we are focusing on coding, on algorithm, since it's the main gate for, as we said, STEAM, IoT, and artificial intelligence. And by doing those exercises, you are making your students think and evaluate and try to see what is the optimal solution. So here in this example, for the arrays, I've did a typical program in order to fill in an array and to search for the item. I will close this exercise, and then after I will switch to another exercise, which is the same as the previous one, but by adding a specific value in order to count how many times a value is found. And believe me that if your students reach the level of understanding this code and writing this code later on, believe me that you should be satisfied from the result, and you should be proud of yourself and of your students, because it's a really
Yes, here, Mr. Sam, here. Have a problem? We can't listen. We can't hear you, Mr. Sam.
Mr. Osam, you're on mute.
Okay, thank you. Just one moment, please. Just one moment.